Hello, everybody, and welcome back from the break. I hope you went to the partner village and took a look at some of the materials. But without further ado, we are starting from where we left off with Monica Posada's talk about the European Union and API policies, and we are going to take on Jari Reini and we are going to talk about geospatial APIs. And I'm so glad I don't need to teach you how to say hyvää päivää, good morning in Finnish, because we speak the same language of APIs and Finnish, I think. So Jari, how are things today in the geospatial world?
All good, and I will give a short introduction to the world of geospatial in brief. With 20 minutes, you will get everything about geospatial.
Yeah, the whole wild and wide world of geospatial, I'm sure. That's great. So, hey, keep your comments and questions coming to the chat, and without further delay, Jari, take the stage.
Thank you, Marjukka, and good morning. On behalf of myself, I'm Jari Reini and working at National Land Survey of Finland. And the weather is sunny here, and everything will run smoothly in next less than half an hour. So my topic today is geospatial APIs, some building blocks, how to create, modify, and actually curate geospatial data on the web. If I just start with short introduction from where I'm coming from. So working at National Land Survey of Finland, we are national mapping and cadastral agency in Finland. Not really a startup anymore. We were established back in 1812, so a bit over than 200 years old. We have around 35, 36 offices all around in Finland, from south to north, from west to east. So we have a quite good coverage in Finland. We of course do some data acquisition. We collect map data, real property data. We provide maps and spatial data through APIs. And we do also some research. We have around 120 researchers in National Land Survey of Finland, and those are working with data collection and APIs and other things, and GPS coordinates, satellite positioning, etc. But during this talk, I will explain briefly how APIs have come together in National Land Survey of Finland and our plans for the future. So some of the key drivers for API development in Finland, and especially at National Land Survey of Finland. First of all, we have quite a lot of data, a big amount of data, and it's updated constantly. So it must be up to date. Timeliness is key for the users. And for that, obviously, it doesn't make sense to just download your content and put it into your local computer, because it's terabytes of data easily. And secondly, it's getting old as soon as you have stored everything in your local computer. And therefore, user needs the data as part of their systems quite often, and it must be up to date. So that's why we have APIs up and running. And of course, we are following all European Union directives, and for instance, Open Data Directive and high-value data sets, from which actually Implementation Act is not yet available. But we have believed that in Open Data Directive also some of our content will be very important. So these are some of the things we've been thinking before we started to work on APIs. If we have just a brief introduction of our API history. So we actually published our first API already 18 years ago. So cadastral parcel information as well as raster maps. And we used some of the standards already back on that time, namely Web Feature Service WFS and Web Map Service WMS. So these are some of the standards from Open Geospatial Consortium, as well as those are ISO international standards. In 2011, we recognized, or we published at that time, that there is a requirement for some versioning policy. We had a lot of different products already available, new coming all the time, and we recognized that it's very important to have some policies, how long we will support the old APIs before we publish some new ones, how we are publishing beta releases, etc., etc. The screenshot on the right-hand side is in Finnish, and that's just for visualization purposes, so not very important in this manner. Then we also published a few years ago some API principles about usage policy, licensing, how we use usage monitoring, and also some guidelines, our restrictions and authorization, as some of our content may be also restricted. And currently, we have about 29-30 APIs up and running in production use, and we also have several beta status APIs also available. And during last 15-20 years, we have had plenty of different projects and of course maintenance work for our APIs as well. So if we now look a little bit what will happen or happening right now and what we've done in last few years. First of all, internet is of course a very important thing, and all the data, or at least most of the data, is published through internet. And back in 2017, OGC, Open Geospatial Consortium, and W3C, World Wide Web Consortium, had a project called Spatial Data on the Web Best Practices. And as the outcome of that project, we had some best practice recommendations, which I just highlight few of them in this slide. You may go to the complete list at w3.org. But some of the things which are very important for our development right now is that we are using unique persistent URIs for our content. Very important also that spatial data is indexable by search engines. That's why we have currently the RESTful APIs. We should have some encodings which are really for target audience, not to using something which is just internally important, but easy to use also for customers. And APIs, of course, should be also very easy and convenient to use. And last but not least in my list, that metadata is very important in delivery, and we are publishing dataset metadata at the same time when we are publishing our actual content. These were just few of the best practices, as I mentioned, and the complete list is available on the web. And based on these recommendations, OGC started to work on building blocks for location. And these are new OGC APIs. Some of the key things in these APIs are to be fair, findable, accessible, interoperable, and reusable. To be findable, we need some catalogs and metadata, which I will come back shortly. Also accessible, we have open protocols, and those are standardized, in this particular case by OGC, and some of those standards are also published through ISO. Then the data must be interoperable, so different content encodings. In our world, in geospatial content, we use JSON, but it has a bit of enhancement on top of that. So it's a GeoJSON, so it defines how coordinates are structured in JSON. We also have so-called GML, Geographic Markup Language, which is XML based. And for convenience for end users, we also publish some of our data through HTML, which is easy to show by search engines as well. And of course, reusable, we have all the license information available. At National Land Survey of Finland, we are using CC BY 4.0. We have different data product specifications for different data teams. So how you will publish, for instance, buildings or addresses or other content. So these are some of the key principles for the implementation of our APIs. If we go a bit into these OGC APIs, in the first slide I represented WMS, WFS. Those standards are almost 20 years old already, and these new OGC APIs are built upon of the legacy of these old standards. More RESTful, resource-centric APIs, and using all modern web development practices, like we are using different HTTP methods, not only get and post, but also put, delete, and patch. So using things which are actually coming already from W3C. And also we are building our standards as building blocks. In the past, our standards or API definitions were very big, and when you try to put those to be compliant, you must implement every single building block or every single statement in the standard. But now we have divided those into the smaller pieces and are a bit easier to implement. And here I have just a screenshot from a map, which is coming from a standard. And on the right-hand side, you can see this geographical markup language. Just a little snapshot of a place name information. It's just a bit very brief introduction to that. But these new building blocks, we have different settings for those. We can deliver data, so we have so-called OGC API features, which is already approved standard and quite widely used. And by using this features API, you can download the actual content as in GeoJSON or GML or in other format. You can define your encoding basically how you would like to do it. Then we have view service, OGC API maps, which will deliver the map image to your screen or to your application. In the beginning, I mentioned also metadata. So we have a new building block coming, which is called OGC API records, also RESTful API in which you can search for data. So it's a metadata service describing the data set itself and all the attributes, licensing information. So you can use that in first place and then find content and then either use download or view service. In addition, we have also a processing service in which you can create your own processes, you can modify your data, you can make some analysis or something like that. So it's a new standardized way of calculate using geospatial content. And then a little bit more detailed or different type of services, coverages and EDR. Coverages API is more for complex raster data and data cubes, and environmental data retrieval more for spatio-temporal information like weather forecasts, where you have a very important part of the service is time as well. So this API defines more possibilities to query your data using time in this API. And if you just deliver your content is one way, but you also can create new content using these APIs, replace, update, or delete. So changing the content, those are not usually publicly available for all the users, or at least requires some authentication and authorization. But you can maintain your data sets back there on the database using these APIs. And as I mentioned earlier, we are using HTTP methods in this. So if you create something new, you just post thing. If you replace, you could use put and update patch and delete when you are deleting content. This standard or API is still in process of development, so it's not published, and there might be some major changes. But just to give you some highlights, maybe not so visible on the screen, but you can see on the top left, I will post something to my server, and the content is below the red box. And then you will get the response back that HTTP 201 that the content has been created. Second example is how to update content. So you actually pass the ID, in this case ob.2. You send the content there, so it has some different information than on the left-hand side. And then you will get HTTP 204 that, okay, the content has been updated. And the delete is quite straightforward. You just send the ID to the server, and the server will return 204 OK to you. And just a brief example how you can use Geospatial API to update, create, and delete content. Next, I will talk a little bit about what we have available, how we are publishing our content using these previously mentioned APIs. First of all, we have mainly our content as open data. So we have topographic database, we have elevation models, we have geographic names, property boundaries. So we have quite a big list of different content, as you can see on the screen. And how we are publishing this content, we have different APIs available. I can categorize those in four different categories. So if we first start with map APIs. So by using this API, you get map back to your server. For instance, you ask a background map from the server and you get back an image which you can then show in your application. Then we have spatial data APIs. These have different themes like place names, roads, buildings, etc. and you can query the actual content. So you get some JSON or GML or other content back, and then you can visualize or use or analyze it in different ways. So in these map APIs, you get an image, but with Spatial Data API, you get some actual content in different encodings. And then I put also here 2 other categories: real estate information API. So we have up-to-date real estate information available at National Land Survey of Finland, and then you can ask for that and you get back it as a JSON or comma-separated file, CSV or other encoding. And the same applies for residential and commercial property information APIs. You get up-to-date apartment information. These first 2, map APIs and spatial APIs, are more used for consumers, like citizens can use those, all small companies. But real estate and residential information is more for businesses. So for instance, real estate agency can use those, or banks can use, etc. So these last 2 APIs require some contract between NLS Finland and the user. We have some contracts also, of course, map APIs and spatial data APIs. Just a few examples. Here I get a map, what you can see on the screen, and I have a snapshot of the API itself and different parameters. So first of all, you just have your access point and then parameters, what layer you would like to have. So in this case, topographic map, and then which width and height you would like to have it. And the last parameter, B box, so-called bounding box, is very important in geospatial community. So you define the lower left and upper right coordinate corners, so you can request the content from that area. And then you can have format and image size available. If we go into spatial information, here I have examples to find cemeteries from Finland. So in this case, I don't have any bounding box available, so it will give you all the cemeteries from Finland. Then in the second example, I ask cultivated land from a region, a maximum 10,000 items, and from a bounding box, so from a coordinate region. And the last example is showing one building, so I'm limiting it to one. It will be a random, but I could also give /items and then the ID, and it would give me the exact building with that ID. And as an example, I have here GeoJSON encoding as an output. Then real estate information. Again, you can find property IDs from some region. Here I again have this coordinate bounding box. So give me from this region all the property IDs. And then we have different APIs also for purchase price information or properties bought by foreigners. In this case, I visualized it in a table, but originally you get encodings. Sorry.
Half a minute. So can you wrap it up so that we can keep the schedule? It has been super interesting.
Yes. So this is an example of real estate information. And then lastly, I have a slide coming with more information. If you are interested in to use and acquire our information, go to our website, nls.fi, or you can use the Finnish version maanmittauslaitos.fi as well. So this will actually conclude my presentation. Thank you very much for your interest.
And before Jari, you go, thank you. And there is one question in the chat. Maybe you can answer at length in the Hopin chat, but how do you maintain the API consistency, both the API input parameters and output? Do you have API versions? If so, how do you manage the API versions? So maybe if you just can quickly answer about the versioning.
Yes, we have a versioning policies, as I had in one of my first slides. So we are using major, minor, etc. versioning policies. And as a background, of course, we have information what data is available there, but I can put those into the chat.
Yeah, that would be great.
Yeah.
Thank you, Jari. And it was the first time I ever saw a cemetery API. I am so enlightened. Thanks, Jari.
Thank you.
And now we